And hello, Barry. Barry is a very long time market analyst and an OLED, evangelist for many years, and a friend in the industry. So thank you, Barry, and you've got the floor.
Well, thank you for inviting me. I'm probably different than every other speaker because I'm been involved in the OLED industry for since it started, and I'm no doubt about it. I'm very biased about it. Uh, so let's take a look at the display industry today. Uh, we have a situation where let me go back. Where revenue has been declining since 2021, uh, when smartphones, TVs, PCs, and monitor shipments peaked. And since that time, it's been decreasing. Uh, by 2024, we hope to recover and start to grow again, but the growth will be relatively small. And has been since the smartphone, no real new applications that have entered the market of any significance. There's currently excess LCD capacity running at 60 to 80% utilization. Smaller LCD fabs are at the end of life, and the OLED share of the market has been growing. Uh, and VR, which is really the new application that I said didn't exist, but has been created over the last 5 years, is actually flat to down in shipments. And the industry seems to be waiting for augmented reality, where I think micro LEDs are going to shine. And really, at this stage, there's no competitor, but there's no market either. Just to take a stronger look at capacity, on the right, you see the growth, and this since 2015, and in the years 23 to 28, there's basically no new capacity. There's one new line supposedly planned for India, and then LCDs have OLEDs rather have a expectation. Samsung is building a Gen 8 8.7 to go after the IT market, and um, and BOE has also just committed something like $30 billion to build another fab, OLED fab for IT. IGZO is becoming more popular, and the mobility is reaching 50 millimeter, 50 per volt, 50 centimeters square per voltage second. The industry continues to remain in excess capacity, and the current Gen 6 and Gen 8.5 OLED fabs are fully amortized. But that will happen by at no later than 2030. What that really means is the one of the big drawbacks of OLEDs in terms of cost has been the cost of vacuum thermal evaporation. A tool of vacuum thermal evaporation tool can cost $1 to $2 billion, and that really represents the big difference in price, especially in TVs and actually in smartphones for OLEDs versus LCDs. And when you take away that cost, the depreciation, the costs are comparable. Okay, so let's look at the micro LEDs. This is kind of the future of the display industry. 11.5 billion has been invested per Yole. Another 3 billion is expected in the next 2 years. This is really small compared to what's invested in LCDs and OLEDs. And OLEDs, is probably more like 100 billion or more. The issues now um, for micro LEDs, get that die size down 5 microns to 1, raise the wafer size from 4 millimeters to 12 millimeters, increase the mass transaction throughput. That's going from 100 million per